Today we ask a question, is Russian armor design falling behind? The West during the Cold War had a lot of respect for Soviet engineering and their tanks. Of course, some people claim that these tanks were overrated, referring to the losses of Russian armor sustained during the invasion of Ukraine in 2022. Although we should not forget that in many cases Cold War tanks are facing off against far more modern anti-tank weapons. Additionally, factors like training, morale, and other facts are at work as well. To discuss this question, we have as a guest the author of Armor, Materials, Theory and Design. Please welcome Professor Paul Hazell.
My name's Paul Hazell, everybody. I'm a professor of mechanical engineering at the University of New South Wales, though I should say that all views I say from here on in are my own and not the university's. I study impact dynamics, so that's specifically looking at the dynamics of impact, as kind of the name says. I've been in Australia for the past 10 years, where I've built a research group focused on looking at how materials and how structures respond to high velocity collisions, so that we can make better, stronger, more resilient armor systems. And that's kind of what I do for my day job. I also teach and write books and articles on the subject of armor.
So is Russian armor design falling behind or not? Is it?
Yeah, it's difficult to know and to be absolutely sure, to be honest, Bernard, because certainly in the 1970s, 80s and 90s, there was some fantastic work that was done by the Russians in terms of understanding ballistic penetration processes and that type of thing. I wonder if Russia has been facing so many problems recently because they've kind of failed to keep up with the rate at which the West have been innovating. So what I mean by that is that, I sincerely believe that universities are sort of the powerhouses of innovation, and don't get me wrong. There's some absolutely fantastic Russian scientists out there. In fact, we find that when we bring them out of the sort of the Russian university sector, and they come and embed within universities in places like Germany, in places like the UK and America and Australia. They absolutely thrive, and they do some fantastic, amazing things for science. But within the sort of the Russian university sector, I think that the academics tend to have quite a high teaching load, so that doesn't give them much of a bandwidth for for doing research. And sure, they can do bits and pieces. Of course, there is the Russian Academy of Sciences that does some incredible science. I've got no visibility to how much armor work occurs in there. But if you look at the history of what's actually happened over the past 20 years, 30 years, the US government has put huge amounts of money into the university sector for defense spending. And that's a big controversy, right? That's controversial for a lot of students that attend university, because they kind of think, well, hang on a minute, I'm attending a university, I'm a pacifist, I don't want all this defense money kind of propping up my institution that I'm studying in. In fact, I remember I was associated with what was called the Institute of Shock Physics at Imperial College London about 10 years ago, and there was a big thing about there's a bit of pushback because it was the Institute of Shock Physics was funded by the atomic weapons establishment, and so there you've got AWE is funding a kind of a program within a civilian university, but that happens a lot. It happens more than people realize. That in fact, in the US, they've got the US Air Force, the Office of Naval Research. You've got the US Army that actually invest in university projects around the planet, and they do that because they understand that universities really are the kind of the powerhouses of innovation, and I don't think that's what's actually happening in Russia, because it's a lot of the work goes to government labs, and again, government lab employees. I mean, there's some fantastic scientists working in those environments, and I know, and some of them are my friends. But within a government institution, you don't get the same level of competitiveness, the same level of hunger that you get within the university sector, because we're all competing against one another in terms of citations, publications, research income, and that type of thing. So I wonder if that's the kind of the root cause of some of the problems that are kind of bubbling away there, and we're seeing some early results of I suppose the way that you invest in innovation. I suppose that's where the issue is. Perhaps there's a big perhaps there.
I mean, I might chime in here a bit because I studied history and computer science, and I remember from computer science I had two very interesting experiences. One friend went to Moscow, I think, for 1 year or 1 semester. And I also had my thesis advisor was a German, but he was at Berkeley as well. And they talked about the education. And you can see what I call an East-West divide, basically. And Austria and Germany are somewhere in the middle. In Russia, there was a lot of mathematics in the computer science. In Germany, Austria, there was still quite a lot, but it's medium. And in the United States, this was way more practical. So math was way more reduced or more applied on the scale. So you have these weird scales. I mean, one of the other interesting aspects which I saw was, I'm not sure if you know the game Isle 2, Sturmovik, which came out in the 90s or something. And I remember looking at the homepage back then and looking at the staff, and they were all former defense contractors, like they were like avionics experts and everything else. And it was like insane. Where I talked with Steven Zaloga about this, there's certain brain drain where he mentions what was also for Ukraine and Russia was previously in the defense industry is nowadays in the computer industry as well, because there's the money and not in the defense industry anymore. And I guess in the United States, since there's so much money in the defense industry, that they're also they have a competition against the entertainment industry as well, probably in many aspects, which is maybe not there in some other countries because they need more money in the other areas, or there's more money to be made. Perhaps. The aspect about competition is interesting at universities because I see a lot of times on Twitter, for instance, that people complain about the competition, and that I read many years ago, like that people said, back then we would publish one major paper on it, and now we basically divide it up into 5 different publications so that we get more citations. So I guess there's a trade-off for everything. You need a certain amount of competition, but not too much, because else it might also break the system probably.
Yeah. So there is very much in the university sector, there is this old mantra, the way you would publish or perish, is still very much alive, and is probably now it's publish and get great citations or perish. So it's become a kind of a publishing game on steroids, I suppose. That's which isn't necessarily a bad thing. I mean, I would say that because really that when you're publishing some work, that you are crystallizing an idea. I'm from the UK, and I remember a briefing from somebody from he's one of the IP guys who was associated with defence, and he was saying that actually, the publishing is a good thing for defence, because one of the problems that you get within government labs is that when they do their excellent research, and some of it is truly excellent, it gets squirreled away in a filing cabinet and forgotten about. And then they go, a few years later, they have to go back and rediscover what because it's all, they've classed it as, you know, top secret and no one can touch it and all the rest of it. Whereas and the US knows this, understands this. China understands this. I mean, you look at some of the defense-related papers that are coming out of China at the moment. It's staggering. The UK understands this. You know, there's lots of papers that are published in a kind of defense sphere, probably more so than people realize. I mean, the you know, obviously when you're talking about a specific application, there has to be some security over that. But when you're talking about fundamentals, and when you're talking about obscure kind of applications, then certainly some of those results are published.
Yeah, I think it also probably depends a lot on the different fields, because I think what I read was mostly about biology and other stuff, and I have humanities and computer science, so they're completely different. It was, for instance, I remember our thesis advisor went into a class and said, I don't like teaching, and he was really good at it, but I invest a lot of time in it because I want you to write papers for me. Because that's how it works in computer science. He said when he started, he had no ideas at all. But now he's a professor, he has so many ideas, but he hasn't time anymore. And this was interesting for me because I had 2 text files, one for ideas for computer science theses and one for history theses. The one for history thesis had 30 or 50 entries. The one for computer science had none. And I was like, when he said, as a student, I had no idea. And I was like, okay, it seems to be similar. And meanwhile, in history, it seemed more or less that the professors only would publish themselves. They would not need somebody to do their work.
Yeah.
Because a lot of my interpretation was, in history, it's a lot about the accumulation of information. So less about ideas. Whereas in computer science, it's a lot about application, and it's probably most extreme because computer science is probably one of the most applied, where you can test it the most easiest way. Because if you want to test something and you shoot at armor or something, that costs a lot. I mean, I guess just filing the safety procedures. Meanwhile, if I want to test something in computer science, yeah, in the worst case, I need to buy a new computer and then implement some stuff. But mostly, you can run simulations or something else. So it's very dynamic difference. And I don't know how biology works. I mean, I knew some that were in the lab, and I guess there are different aspects there as well.
Yeah. So in science generally, I mean, experiments and results are a team effort. I mean, they very much are a team effort. You do need, ideally, a kind of a multifaceted team that can contribute their little element to the paper and the project.
Thank you very much for your insights and time.
Thank you. It was a pleasure. It was good fun talking to you, Bernard.
Thank you for watching, and see you next time. Bye.